Hey everyone, welcome back to Math 11. So in this video we're going to be looking at section 8.2, which is kind of continuation with solving problems involving rates. So in the previous video we started talking about rates, unit rate. So let's take a look at a few more examples of how we can use rates to solve some of these questions. So example number 1 says Jeff lives in a town near Canada-US border. It says the gas tank in his truck holds 90 liters. He can either buy gas in town in Canada at $1.06 per liter or travel across the border to the US and fill up at $2.86 US, that's US dollars per gallon. Which would be smarter financial decision for Jeff? Well, it's going to depend on a couple of things. Of course, the price of gas and the conversion rate, which in this case, the conversion rate is not given in this question. So I just picked a conversion rate that we can use. It might not be the current conversion rate, but just for the purpose of this question. So we need to know the conversion rate between the Canadian dollar to US dollar, and we also need to be able to convert gallons to liters. So there's two things we need to know, right? So the exchange rate we're going to use here, that $1 or 1 USD dollar is going to equal to, so I don't need the dollar sign if I write USD, just write 1 USD equal to 1.02 Canadian. And that's probably not the current rate, but whatever, that's what I had in my example in my solution already. And of course, we also need to convert gallons to liters. So we're going to say that 1 gallon is equal to 3.79 liters. So those are two conversions that we need in order to do this question. Okay, so let's take the Canadian price first and see what we can do with this. We have $1.06 per liter. So if he fills up in Canada, if he fills up the full tank and full 90 liters, so let's write Canada here and do the price per liter. So we have, this is Canadian dollars, 106. So the liter is going to go on the bottom, per liter, times the 90 liters, times 90 liters. So as you can see here, the liters and liters will cancel out. You're going to be left with dollars, Canadian dollars. So this equals to 95.4 Canadian. So this is Canadian dollars. All right, now what about US? Well, first let's convert this to gallons to liters, and then convert the currency from USD to Canadian dollars. So if he goes to the US, let's take his rate, 2.86, and this is US dollars per gallon. Now 1 gallon is this many liters. So what we can do to skip the additional step of converting it, we can just replace the 1 gallon with 3.79 liters. So we know that 1 gallon is this many liters. You can just plug in it here. Or what you can do, if you do want to show every single step, you will write 1 gallon and then do the middle step, which is getting rid of the gallon. So which means the gallon is on the bottom, so here has to be on the top, and the liters has to be on the bottom now. So then we know that 1 gallon is 3.79 liters. So this way the gallons will cancel out. You're left with dollars per liter, and then multiply by the amount of gas that you want to purchase, which is 90 liters. So 90 liters. So this way the liters will cancel out. You're going to end up with just dollars. So after you do this math, you're going to end up with 67.92. In this case, this is USD dollars, so US dollars. So before we decide whether that's something that Jeff should do, let's convert USD to Canadian dollars here. So that's going to be our final step here. Convert the currency from US dollars to Canadian dollars. Well, if I use the rate that I already had in my example, this rate right here, I mean, you can do this calculation with your own car at home and use the current rate, conversion rates for the currency, and see if it's feasible. Well, right now the borders are closed, but nevertheless, that's something that we can do because we do live close to the US border. So let's take the 67.92. This is USD, so we want to convert it to Canadian currency. So I'm going to just cross multiply. I'm going to set up my cross multiplication problem. So my conversion factor is at 1 US dollar. So this is, maybe I should just use, do it like this, USD. 1 USD is going to be X CAD and 102 CAD. All right, so that means we need to cross multiply to find X. So whenever we cross multiply, multiply the two that are known and then divide by the leftover. So in this case, you just divide by 1, which is just not going to change the value. So our X is going to equal to 67.92 times 102, and then divide by 1. Well, in this case, that's not going to change anything, but that's the full step. So we're going to end up with 69.27 Canadian dollars. So in this case, if you compare the price 95.4 versus 69.27, this is cheaper, right? Depending how close Jeff lives to the border, it might be worthwhile going to the US to fill up his tank or not. If you may be living too far and it takes too long to get through the border and it's not worth your time, then maybe you just want to fill up in Canada. Also, you know, the prices vary from time to time, and also the exchange rate varies. So it all depends on what's going on in the time that you want to do this. So this is just an example which you can use to actually calculate this sort of stuff at home. Now let's take a look at another example. So in this case, we have Paula is asked to order snacks for the office meeting for 180 people. She decides to order dessert squares, which come in boxes of 24. She estimates that she will need 2.5 squares per person. How many should she buy? Now, it doesn't mean that people are gonna split a square and every person gets 2.5 squares exactly. That just means some people will eat 3 or 4 and other people will eat like 1 or 2. So on average, you're gonna need about 2.5. That's what this means. So how do we do this? Well, let's start with the number of people that we have. We have 180 people that we need to buy food for. So we have 180 people. Okay. Now we know that we want this many per person. So let's multiply by this 2.5 squares per person. So notice the units people and person are the same here. So these will reduce away. You're going to be left with the number of squares that you need. Now we also need to know how many boxes she needs to buy. So we know there are 24 squares per box. So let's now take care of the number of boxes. So squares are on the top, which means that we need to have numbers of squares on the bottom and number of boxes on the top. So we know that there are 24 in one box. So one box carries 24 squares. So maybe I should just write box here. So now we get rid of the squares and we're left with just the number of boxes, which means that we need to multiply 180 times 2.5 times 1 divided by 24 to get the total number of boxes. So here we're going to end up with 18.75 boxes. And of course, you can't have 3/4 of a box, so we need to round this up to a full number of boxes, which means, let's write it down, we need to round up to 19. To 19 boxes, because you can get 18.75 boxes, which means that Paula will need to purchase 19 boxes of squares. Okay, so that's question or example number 2. So the last example, again, these are just problems that deal with rates, and I hope a lot of this is reviewed from your junior math courses. Let's take a look at the last one here. This one says Amelia walks briskly at 6 kilometers per hour. When she walks at this rate for 2 hours, she burns 454 calories. Now, Bruce walks at a slower rate of 4 kilometers per hour, burning 62 calories in 30 minutes. If Amelia walks for 3 hours, how much longer will Bruce have to walk in order to burn the same amount of calories? So you can either go fast or run and burn more calories in shorter time, or you can walk slower over a longer time and burn the same amount of calories. So that's what this example is comparing here. So Amelia is walking faster, Bruce is walking slower, but the goal is to burn the same number of calories. So again, there's more than one way you can solve this question. So I'm going to start with Amelia here and see that she walks at 6 kilometers an hour. So I'm going to say at 6 kilometers per hour, she will burn. We know the rate, 454 calories in 2 hours, right? Because that's the time. So what is her hourly rate? Well, if you take 454 divided by 2, that's going to be 227 calories per hour. So this is calories per hour. So if she walks in for 3 hours, it says if she works for 3 hours, how many calories is that going to be? Well, for 3 hours, let's take the hourly rate of 227 calories per hour and then multiply by 3 hours. So again, the hours and hours will reduce away, and you're going to end up with the amount of calories that she will burn in 3 hours. So that means that she will burn 681 calories in those 3 hours. All right, so now we know the amount of calories that Bruce has to match in order to have the same number of calories as Amelia. Now, Bruce is walking slower. So he's walking at 4 kilometers an hour. Okay, so, and burning 62 calories in 30 minutes. So 30 minutes is half an hour. Because we have kilometers per hour, we had to match our time here, so we have to have the same time units. So remember, 30 minutes is 0.5 hours. So let's take our calorie burning units of 62 calories per 30 minutes, but we're going to change this to 0.5 hours because we want to match our time to hours. So we're going to write 0.5 here, 0.5 hours. This gives us the amount of calories per hour that he will burn. So 62 divided by 0.5 is basically just multiplying by 2. 62 times 2 is going to be 124. And the units are calories per hour. So now we know the calories per hour rate for Bruce. Okay. Now he wants to match the same number of calories as Amelia, so he wants to burn the same number of 681 calories in his walk, but he's walking slower. So let's take his rate, 124 calories per 1 hour, and write down the cross multiplication problem. Now the goal is to match the same number of calories, so I'm going to write the same number of calories as Amelia on the same line as calories, so 681 calories. And then the time is going to be unknown. So how many t is the unknown? So that's what we need to find. So again, we're going to cross multiply here. So a lot of these problems with rates are basically cross multiplication problems. So we're going to multiply these two together, divide by the leftover number. So t is going to equal to 681 times 1, which is just 681. But we can write it in. And divide by the leftover number, which is 124. To get the time. So this equals to 5.5 hours, which means 5.5 hours, right? So 5 hours and 30 minutes. So in order for Bruce to match the same amount of calories that Amelia burned, he needs to walk longer for 5.5 hours. As compared to her, she walked this in 3 hours, so 2.5 hours longer than Amelia. All right, so that's the last example for this section. And again, the practice questions you're going to see in the textbook are just, again, word problems for the most part, where you have to set up your problem, convert some units, and then, like I said, most of these questions are going to be cross multiplication questions. So there's a summary in your textbook, and I put it here. So make sure to read through the kind of key ideas and how to approach problems. And again, like I said, there's more than one way you can solve a lot of these questions. You can do each cross multiplication separately. You can combine it in multiple steps in one calculation. It's really up to you. So make sure you look through the examples in the textbook, see if it's done differently, and see if you like that approach better. So for homework, we're looking at scale model. So we're section 8.2. So make sure you read the examples, page 462 to 466, and do questions 1, 3, 8, 12, and 17. Okay, if you have any questions, make sure you post them as replies on Teams.